Chemistry is the study of matter. And since hair is matter, every successful professional cosmetologist should understand chemistry. In this chapter, you will explore 3 areas of chemistry as they relate to cosmetology: matter, the pH scale, and the chemistry of cosmetics. Our first chemical topic is matter, which covers anything that occupies space. All matter exists in 3 forms: solid, liquid, or gas. Hair is matter. Shampoo is matter. Oxygen is matter. Chemistry is the scientific study of the physical and chemical changes of matter. For example, when this tray of water freezes and changes to ice, that's a physical change. The ice is still water, but now it's a solid instead of a liquid. An example of a physical change in hair would be the temporary change that occurs when air forming or drying wet hair. An example of a chemical change occurs when hydrogen combines with oxygen to form a new substance, water. In hair, an example of a chemical change occurs when the hair is permanently altered into a new curl configuration through the use of processing solutions. Whether liquid, gas, or solid, all matter is made up of chemical building blocks called elements. There are over 100 known elements in the world. Hair is composed of 5 elements: carbon, oxygen, hydrogen, nitrogen, and sulfur. Just remember, cones: carbon, oxygen, hydrogen, nitrogen, and sulfur. And you've got the chemical symbols for all the elements that make up hair. All elements are composed of atoms. An atom is the smallest complete unit of any element, and it looks a lot like a solar system. Every atom has a nucleus, which is made up of protons and usually neutrons. Around the nucleus are orbiting electrons. The number of protons in one atom establishes its atomic number. Hydrogen, the simplest atomic structure, has 1 proton and 1 electron. When atoms combine chemically, they form molecules. A molecule is 2 or more atoms joined together by a chemical bond. Water is an example of 2 hydrogen atoms combining chemically with 1 oxygen atom. Hair is created with similar chemical bonds that eventually create the building blocks of the protein for hair. This happens through chemical bonds, beginning with amino acids. Amino acids create all proteins. Every amino acid is composed of carbon, nitrogen, oxygen, and hydrogen atoms. Hair is a form of protein called keratin. Keratin in hair contains 19 of 22 common amino acids. Hair is made up of 97% keratin protein and 3% trace minerals. These amino acids join together in chains, in a specific order and arrangement to become proteins. When 2 amino acids are positioned end to end, the acid end of one amino attaches to the amino end of another. The bond created is called the peptide bond or end bond. As a stylist, you will be altering these links. You need to know how your tools, techniques, and the chemicals you will be applying will affect your client's hair. It's important for you as a stylist not to disturb the peptide bonds. For instance, combining alkaline chemicals and heat could break these critical peptide bonds and destroy the protein structure. The result? The protein chains separate into small fragments, or revert to groups of different amino acids that no longer have the characteristics of hair. Next, let's take a close-up look at the keratin protein of hair. Notice it has a spiraling configuration. These spiraling chains can be linked and held together by 4 side bonds. Each bond has its own characteristics and serves a different purpose in building hair. The bonds are the hydrogen bond, the salt bond, the disulfide bond, and van der Waals forces. The use of chemicals on hair affects all of these bonds, so it's important for you to understand how the 4 side bonds work. The first bond, the hydrogen bond, works on the principle that unlike charges attract. Hydrogen bonding occurs when the hydrogen atom in one molecule is attracted to an atom of another molecule with many negative electrons. Hair has millions of hydrogen bonds in its structure. They are weak and easily broken down with heat or water. However, because of their numbers, they give hair its shape and provide about 35% of its strength. The salt bond is also a result of unlike charges attracting. Here, the negative charge in one amino acid grouping attracts the positive charge in another amino acid grouping. They also account for about 35% of hair's resistance to change. Because of the nature of salt and hydrogen bonds, hair can be shampooed, set in rollers, and reformed with any styling tool to create a new shape. That's because when the hair is saturated with water, the hydrogen and salt bonds are weakened, leaving the hair more pliable. However, it's only temporary. Exposure to water or even humidity can break the new bonds and restore the original ones. The disulfide bond is formed when sulfur-type side chains join with other sulfur-type chains. Many chemical services, such as perming and relaxing, directly affect the disulfide bond by either breaking the disulfide bond or reforming it in a new shape. This process is a chemical change. The van der Waals forces bond is not important for the stylist. Just remember it exists and does play a role in bonding protein chains. Let's review. Hair, like all matter, is composed of individual atoms, the smallest unit of matter. These atoms unite by sharing electrons to become molecules of amino acids. There are 22 common amino acids. End or peptide bonds are formed when one end of an amino acid bonds to the opposite end of another amino acid. Amino acids link together to form protein chains. Hair is a form of protein called keratin. Side bonds link individual protein chains side to side. There are 4 types of side bonds: hydrogen bonds, disulfide bonds, salt bonds, and van der Waals forces. The bonding of protein chains to other protein chains makes human hair.